Hey, how's it going, everybody? Welcome to Science Night. I'm DC Larrabee. I'm going to walk through an investigation with you tonight that has to do with the conductivity of water. I call this experiment everyone out of the pool. And what we're really going to do here with you is we're going to model the scientific process. Okay, so when we start off the scientific process, really what we want to do is we want to start off by identifying a problem or developing a question that's going to help to guide us through the investigation process. So what we've done here is I've developed a question. Now remember, this is called everyone out of the pool. So maybe when you guys go to the pool, somebody will blow a whistle and they'll say, everybody out of the pool. And that's probably because there's an impending storm, there's going to be some electrical energy in the air, and lightning might strike the pool and shock everyone in the pool. So why would everybody get shocked in a pool? To start off with, you probably need some background information. Water is actually not electrically conductive. Hydrogen and oxygen combined as a molecule is not actually electrically conductive. So why do you have to get out of the pool? So that's what we're really going to investigate. And here's our starting question. We all know that pools have chlorine in them. Well, to work with chlorine, it's a little bit toxic. We probably don't want to work with chlorine. But salt, table salt, sodium chloride, actually has an atom of chlorine in it. So we can use chlorine from sodium chloride to run this investigation and keep it safe for everybody. So here's our question. Our question is, how does adding sodium chloride, salt, to water affect the electrically conductive properties of water? Okay? So any good question is going to have very easily identifiable variables. Independent variables, which are the cause or the action, and dependent variables, which are the effect or the reaction. So let's see if we wrote a good question here. How does adding sodium chloride to water affect its electrically conductive properties? I think this is pretty straightforward. Our independent variable, our cause or our action, is going to be the actual adding of sodium chloride to water. Our effect or our reaction is going to be how the adding of sodium chloride actually changes the properties of water. So is it going to make it more electrically conductive or less electrically conductive? Okay? So now that I've identified my independent and my dependent variable, I'm going to take my original question, I'm going to use those variables to rephrase my question and turn it into what is known as a hypothesis, an educated guess. Okay, so here we go. Here's my hypothesis. And you can see I just took my independent and dependent variables, I just recycled the wording of my question, and I wrote a very comprehensive hypothesis that will help to guide me through the investigation process. So adding sodium chloride to water will increase, and I have to make a decision here, or decrease the electrically conductive properties of water. Now, based upon what I said before, everybody out of the pool, my best guess, based upon my prior knowledge, is that it will actually increase the electrically conductive properties of water. So I know that there was a dualism here. I could have said increase or decrease. I'm going to get rid of the decrease because I'm guessing that it's actually going to increase the electrical conductivity of the water, okay? And it's going to change its properties in that way. So adding sodium chloride to water will increase the electrically conductive properties of water. Okay, the next step in our investigation process, now that we've identified our question, we've developed a comprehensive hypothesis, is to really start figuring out, wow, what the heck are we going to need to perform this investigation? So we start off with a materials list. Our investigation is pretty straightforward. We don't need a lot of materials. We're going to need water, we're going to need our table salt, our sodium chloride, that's where we're going to get our chlorine from, okay, the stuff that's in the pool. We're going to need a 6-volt battery, we're going to need some insulated wire. I like to have red and black insulated wire, red for positive, black for negative. We're going to need alligator clips to put on the end of our wires, test tubes, okay, test tube rack to hold those test tubes. And then we're going to need some holiday lights, and we're going to make our circuit out of holiday lights just to tell how electrically conductive the water actually is. Now that we have our shopping list, essentially, what I like to do before I actually start using the physical parts is develop a diagram. Because a diagram is a visual model that I can use that's complementary to the model that I'm ultimately going to make that can help me to figure out the process and work the bugs out before I get started on my investigation. So here we go. I've drawn a diagram. And all of our material lists are out there now, okay? And we're showing the uses for our materials. I've got my 6-volt battery. I have my positive wires and my negative wires going from my 6-volt battery into my test tube. Okay, my test tube has a little bit of solution in it. And you can see the positive and negative wires going into my solution. They're not touching each other. That's important to note. I've got my test tube rack holding my test tubes. I have my holiday light set up as a circuit right here on my positive feed. And I just have all of my pieces in place. Now I'm going to use this to write my procedure and to actually make my physical model. So here I go, I'm going over here to my procedure. The first step in my procedure is always gather materials. I need these materials to conduct my experiment. Okay? So I went shopping essentially and I got all my materials. Here I am now, I'm at step 2. So what am I going to do for step 2? Step 2 is I'm going to go ahead and I'm going to measure out 40 milliliters of water in a beaker. You don't need to use a beaker, you can use anything you have at home. A Dixie cup is fine. Just keep it consistent. I'm going to put my water into my test tube. So step 2 was measure 40 milliliters of water. Okay, and I actually performed step 3 also. Step 3 was to pour that water into a test tube. So you're going to notice that I never leave a step out. Okay, even if the step seems insignificant, like pouring water into a test tube, I don't leave that step out. Okay, and that's really important that you never leave a step out either. Okay, so we just took you through the first couple steps in the process of developing the model to perform the investigation. Now we're just going to quickly run you through the rest of these steps, and we're going to have a lab assistant come in and help us with this process. So we poured the water into the test tube. We're going to run what's called a controlled experiment. Any good experiment is going to probably be a controlled experiment. What this means is you're going to have a test group and you're going to have a control group. Your test group is actually where you're going to test your variable. Now our independent variable in this case was adding the sodium chloride to water, and we were hoping that our result was going to increase the electrical conductivity of the water itself. Okay, so our test group is going to have salt in it. Our control group, we're just going to leave it as pure water, okay, because we want to make sure that we're getting real results, and we're not going to know whether or not we're getting real results unless we have a test group and a control group. Okay.